Now see here. We studied in the previous lecture that normalization is used to reduce or eliminate redundancy in the database relation. Redundancy in the database relation. Understood? Now see here, what are the problems because of redundancy? We are in normalization, we are reducing or eliminating redundancy, means repetition of data in the database relation, means there are some problems due to repetition of data, that is due to redundancy in the database relation. That is the reason we are reducing or eliminating redundancy in the database relation. So see, what are the problems because of redundancy? These problems are also known as database anomalies. Database anomalies means problems because of redundancy. Anomalies means problem. Listen carefully. Anomalies means problems. Problems because of redundancy means problems because of data repetitions is known as database anomalies. See here, this is written problem, this is written problems. Problems because of redundancy is also known as database anomalies. See, there are three types of database anomalies. First is insertion anomaly, second is deletion anomaly, and third is updation anomaly. Before seeing the definition of these anomalies, let us first understand what are these anomalies, which is occurring because of redundancy, because of repetitions of data. In this example, see here, if we insert some record, in this relation R, suppose I want to insert course information, I want to insert course, that is course ID, course name, and instructor. If I will insert course ID is C4, course name is CO computer organization, and instructor is Hayes, HAYEH. I am inserting some course, that is course ID is C4 and course name is computer organization and course instructor is Hayes. Now can I insert this record? I am not inserting fees, I am also not inserting student information, that is student ID, student name, and date of birth. I am not inserting student information. I am not inserting yes ID, yes name and date of birth and fees. I am only inserting course, that is course ID is C4, course name is computer organization, and instructor is his. Can I insert this record? No, I can't insert this record. Why I cannot insert this record? Listen carefully. Why I cannot insert this record? Because as we know that SID CID together is the primary key. SID CID together is the primary key, means SID and this CID together is the primary key, and we know that null values are not allowed in the primary key. Null values are not allowed in the primary key, we have studied earlier. So SID cannot be null here. SID cannot be null here because SID is the part of the primary key. SID CID together is the primary key and null values are not allowed in the primary key. So SID cannot be null here. We have to provide some SID here, means we have to store student information here, means we have to store at least one student information here. SID means student ID, means we have to store at least one student here. We cannot store this record without storing at least one student information here. See here, SID, yes name, date of birth. SID, yes name, date of birth is the student information. We cannot insert course without inserting at least one student information here. This is the insertion anomaly. This is the insertion anomaly. See here, what is insertion anomaly? To insert same data, to insert some data must require other independent data. Sorry, this is sum. To insert some data, to insert, this is sum. To insert some data, to insert some data, to insert course information, to insert some data must required other independent data, must required other independent data. Student information is the other independent data and course is the other independent data. To insert some information must required student information, at least one student information, means to store some information, some data, we required other independent data. That is the insertion anomaly. See here, to store course information, to store course information, course ID C4, course name computer organization, instructor head. To insert course information, at least one student must exist per course. At least one student must exist per course means at least one student must enroll in the course C4 COH. This student information cannot be empty. Why this student information cannot be empty? Because SID is the part of the primary key. SID is the part of the primary key. SID CID together is the primary key. So SID cannot be null. Null values are not allowed in the primary key. Now see second, deletion anomaly. What is deletion anomaly? Now see what is deletion anomaly. If I delete some student information, suppose I want to delete one student information. Suppose I want to delete student ID as 3, student name B, and date of birth is 1996. I want to delete student whose SID is S3, whose S name is B, and whose date of birth is 1999. Means these three students are the same. I want to delete some student information. This is student information. For this, I have to delete these three records. I have to delete these three records. Means I will have to delete this record. I will also have to delete this record. I will also have to delete this record. To delete one student information means to delete the student whose SID is S3, whose S name is B, whose date of birth is 1996. To delete one student, we have to delete these three records. We have to delete these three records. See, we have to delete these three records. Due to deletion of these three records, see here, these two courses are also deleted. See here, this C1 whose course name is database and instructor is course is deleted, but no problem because this course is also available above. This course is available here, but these two courses, course C2 whose course name is operating system and instructor is Galvin, is deleted, and now nowhere C2 operating system Galvin is present. And now C3 Elko course name is also deleted. Now the course whose course ID is C3 and the course name is Elko and the instructor is Coleman is not available here. So because of deletion of this single student information, we need to delete these three records. Due to deletion of these three records, we are also losing course information. We are losing the course information C2 whose course name is operating system. We are also losing the course information C3 whose course name is Algo. So this is the deletion anomaly. See, deletion anomaly, because of of deletion of some data, because of deletion of this student, because of deletion of some data, because of deletion of some data also deletes other independent data, because of deletion of some data also deletes some independent data, because of deletion of student information we are also deleting the course information. Because of deletion of student information data also deletes course data, because we are deleting the student whose SID is yes3, whose yes name is B, whose date of birth is 1996. We are also deleting the course information. Which course? Course C2, whose course name is operating system and instructor is Galvin. Course C3, whose course name is algorithm and instructor is Coreman. We are also deleting these two course information. This is the deletion anomaly. Now see what is the updation anomaly. Now see what is the updation anomaly. Now see, these three records contain the same student. This is the same student in the three records. S3B 1996, S3B 1996, S3B 1996. By chance, if someone says that the student date of birth is incorrect, by chance if someone says that the student date of birth is incorrect, means 1996 is incorrect in these three records and we need to update it to 1998. We need to update it to 1998, means this is the 1998, means I will have to update it in three places. I have to update it in three places, here, here and here. But if we failed to update these two places and we are updating it at only one place, and if we fail to update it these two places, then it causes some problems. This is known as updation anomaly. This is known as updation anomaly. Updation anomaly means if some redundant copy updated, means these are the redundant copy. If some redundant copy updated, other redundant copy failed to update, which causes inconsistency. देखिए, these three are the redundant copy, means repetition of same data. And if some redundant copies are updated, if we are updating 1996 and these two copies are failed to update, then it causes inconsistency. Inconsistency we have studied earlier. Inconsistency means inaccurate, incorrect, not correct. Inconsistency means not correct, inaccurate, incorrect. See here, because I have updated this to 1998, sorry, I have updated this 1996 to 1998, but we failed to update these two, so it is the incorrect data. These two are incorrect data, that is, it causes inconsistency. Inconsistency means it causes incorrect data, inaccurate data, not correct data. See, though this is the updation anomaly, see here, we were discussing what are the problems because of redundancy, means repetitions of data. What are the problems? That is known as database anomalies. What are the problems? Insertion anomaly, deletion anomaly and updation anomaly. And what are the regions of this anomaly? Redundancy, repetition of data. And what are the regions of redundancy of data? If two or more independent tables are stored in one single table, then it may cause redundancy, means repetitions of data. So to remove these anomalies, to remove these problems, insertion, deletion and updation anomalies problems, we have to reduce or eliminate. To reduce or eliminate these anomalies or database problems, we need to reduce or eliminate redundancy in the database relation, and normalization is used to reduce or eliminate data redundancy in the database relation. Understood? Normalization is used to reduce or eliminate redundancy in the database relation. Okay, thank you.